So let's consider a washing machine example. What are the different functionality we have it in washing machine?
Time settings is there.
Right. We have time setting.
Then different types of like
Modes
types
of
of
washing,
washing.
right? Yeah,
Yeah.
modes of washing. Then we have a display features, right? Like what mode it is operating. We have the display feature, and we also drive the motors, right? I mean, internally it drives motor,
Yes.
right? So this operation, whatever is happening, it's some kind of controlled way, right? I mean, some kind of computations are happening. See that setting time. So somewhere, like in some memory or somewhere, it is noting some time. And whenever that time arrives, it is going to stop the washing machine. And whenever like it reaches suitable time, it is going to drive the motor. It is going to drive the pump of the water, like it is to has to draw the water, and it has to rinse at certain time. And whatever the configuration you give it to washing machine, it is going to display that in the 7 segment or LCD, depends on the type of washing machine what you use. So internally, to do all this, we should have some computer, right? Computer. So we have two choices. One is like our microprocessor, or another is microcontroller. This is nothing but these two are a type of computer, in the sense like whatever the interfaces we discussed with respect to washing machine, internally it is like brain of that machine is like microprocessor or microcontroller. If I consider microprocessor, if I want to have some complex computation, like if you want to have some digital signal processing, or if you want to have complex image processing, like in your mobile, you do a lot of you use a lot of applications, right? Like image editing, image processing, you do all. But whether in the washing machine do we have such large scale complex computation? No, right? We just simple we do some simple arithmetic, like maybe like we have to keep the time and we have to control the motor. Some simple control application. I mean, rather than processing application, right? We do actually we use basically control application, right? It is mostly control application, not any processing application, right? Are we doing any image processing or signal processing in the washing machine? No, we basically use control application. That is where the microcontroller comes into picture. Okay, whereas the microprocessor is something like where you have complex image processing, digital signal processing, mostly on computational application. Computational application. Whenever you want to do some computational application, we use microprocessor. Okay, so coming to microcontroller, what is the difference between microprocessor and so in case of microprocessor, we will have one CPU. CPU is where all our computation happens, right? ALU, like arithmetic and logic operation happens. And whatever the external peripherals are there, memory or IO or interfaces, everything we externally connect to it. Externally connect to it. That is the reason, because the reason behind this particular configuration is like, for example, when you go to buy a mobile or laptop, like what do you ask for actually? For example, you go to buy a mobile. So what do you look in that mobile apart from the physical appearance of that mobile?
So internal features, storage, everything.
Storage, what is the speed, right? So based on the
Yeah.
application, we are going to change the configuration of the memory. Like it can be, like, you get various configuration, right? Memory 4 GB, 8 GB, or internal memory 128 GB to 56 GB. So depends on application. Here in the microprocessor, since it is a general purpose, it can be used for any other application. So everything they have made configurable. Whereas in the microcontroller, mostly for the control application, I don't want like huge memory here. If I say I need 120 kilobits of memory, that is sufficient, right? So mostly like here, are we focused on storing anything? Are we storing like washing machine data or something like that? No, right? So it's like mostly control application. So in that case, here we have to externally add. Whereas in the controller, you will have central processing unit followed by all the peripherals, like your memory, timer, UART, all these peripherals, we say it as peripheral in a single IC. If you buy one IC with some pins, everything is within that IC. Whereas here in the microprocessor, the CPU only you will get it inside the IC. So rest of the things you externally interface. Did you get some basic idea?
Yes, sir.
Yeah. So then there are like many other differences as well. So here, in terms of memory, okay, we saw that like whether for the microprocessor, whether it is an internal memory or external memory. It's a external memory, right? Externally we add it. In the microprocessor, we don't have inside the IC, we don't have memory, right? I said like we have to externally add it. So in the
Yeah.
microcontroller, we have internal memory. For data storage and instruction storage, like program. So here in the microprocessor, the interfaces like UART, timer, whether it is internal or external, it is external, right? Whereas here, all the interfaces, this we call it as interfaces or peripherals. These are internal to the memory, internal to the microcontroller, right?
Yes.
So another difference, usually these microprocessors operates few megahertz to few gigahertz speed. Whereas since microcontrollers are basically intended for your control application, it will be in megahertz. The clock speed of this microcontroller are in few megahertz. Now, there are various microcontrollers. So if you consider from NXP, we have LPC 2148. So now from Intel, we have 8051. So our focus, I mean, this is like two examples. Like there are like hundreds of different microcontroller vendors with different configuration, like different number of UART, different size of memory, different number of input output pins. So our major scope of discussion for today is 8051. We will be discussing 8051 microcontroller. Some of the features of 8051 microcontrollers are we have basically 128. This is also one of the important question usually they'll ask. What are the features of 8051 microcontroller? So we have 128 bytes of on-chip memory. Okay. And we have two 16-bit timers. Okay. and we have 4 kilobytes of RAM, ROM, read-only memory for storing programs. And we have 5 vector inputs. Okay. These are some of the features of 8051 microcontroller. Okay. So we have 128-byte on-chip memory, 2 16-bit timer, 4 kilobytes ROM, read-only memory, and 5 vector interrupts. Okay. And coming to your pin diagram, the configuration, like how 8051 microcontroller looks, you see the hardware circuitry of 8051, right? So basically, it has total 40 pins. 40 pins. Just let me show you the image of that. So we have, if you see this is the pin diagram of 8051. So total we have 40 pins. And you can see like the naming conventions like P1, P2, P3, and P0. These are called ports. Okay, ports. So for example, if you want to connect one LED to this one of the pin, then we have to use ports for programming this, blinking the LED or reading some status, etc. So such 4 ports are there in 8051. 4 ports. And each port has 8 pins. How many ports do we have? How many ports do we have?
4.
4 ports. We have 4 ports, and each port has how many pins?
8 pins.
8 pins. And some of the pins, right? So, I mean, if you consider this way, so total 32 pins are used for 32 pins are used for your ports, right? Ports. But how many pins we have in 8051? We have 40 pins. So in that remaining 8 pins will be some voltage inputs like VCC, you can see here. And some pins are ground. And we have like memory, external memory interfaces. So 3, 4, 5, and we have the external clock inputs, like any digital circuitry, if you the sequential circuit, if you want to operate, then we want clock. So total 7. Where is one more? 3, 6, 7, and here we have reset signal, right? So these are the external pins. But apart from that, the rest of the 32 pins are used as port. And in that, port 3, right? Port 3 is a dual function pins. The port 3, you can see also it has some other functionality, like it is used for your UART, RXT, TXT for communication purpose. I said there are interrupts. So like P3.2 and P3.3 used for interrupts, and T0, T1 used for timer. So this is used for memory interface. Same way, port 2 is also used for your address for external memory interface. Okay. So here also you can see P0 also used as a address. So this port pin number 1 to 8, right? So that is port 1. It doesn't have any other functions, but it is internally pulled up. Internally pulled up. In the sense, by default, these pins will be high. If you connect one LED, so by default, this will be high. Internally pulled up to 5 ohms. So if you make explicitly 0, then only these pins will become 0. And it is also bidirectional pin. It can be output or input. Okay. So, and this is used for like resetting the microcontroller. What do you mean by resetting the microcontroller? So if you are running some program, for instance, if you want to bring to the initial condition, then what you have to do? You have to reset the microcontroller, right? You'll be pressing that reset button. So everything will be reset to the original condition. Like how, what is the state when you switch on the microcontroller, right? It will come to that state. And RxD and TXD used for your serial communication, like UART. So these two pins, right, we use for connecting the external clock or external crystal. Okay.
Yes, sir.
And this pin number 20, it is actually power supply ground. Always be any circuit, for example, you want to glow an LED, you have to connect VCC and ground, right? So this is basically used for grounding. Okay. So this pin number 29, 30 and 31 used for external programming memory. Okay. So these are actually, if you are external memory interface, if you are using, so these will act like a lower address by higher address by AD0 to AD7 and A15 to A8. So this will act like a address lines. So this is also one of the important question. So they will ask you like explain 8051 with like a pin description of 8051. In that way, they'll ask the question. Okay, you have to explain these features. Okay. Anyway, I'll share you this recording also. If you are not able to catch up now, right? So later you can actually watch that and again and you can catch up this one. Okay.
Okay, sir.
So at 8051, what we have is actually 8-bit CPU. What do you mean by 8-bit CPU? All the operations, what happens inside the 8051, the addition, subtraction, registers, all are 8-bit. We operate using 8-bit. So what is the maximum value we can have using 8-bit? Always when
0
I
to
say
16.
no. So whenever I say any number of bits, so maximum value what I can have using that number of bits is 2 power that many bits. So 2 power 8. That is 0 to 255. This is the maximum value what I can have using. I can operate in 8055. And I have 16-bit program counter. I have 16-bit program counter. So program counter is nothing but, so I will be storing all the program in the memory, right? The program memory. I will have program memory. So that if it is program memory is external, then this 16-bit program memory is nothing but it can have 0 to 2 power 16, that is 64K. So you can store 64K different instruction inside the programming. So it will say which line of the code you are currently executing. Program counter will say, you will have like whatever the program you write in 8051, that will have like n number of lines, right? So the program counter will say which line of the code you are executing currently. Okay. And we have 8-bit PSWR, program status word. Okay. In the sense, this whenever you perform some operation inside the microcontroller, it can be addition, subtraction, multiplication, you will generate carry. Your result may be like 0. Your result may overflow. Your result may be negative. So all these status, you can see it in program status word register. Okay. And some times back, I told you that we have internal RAM. What is the size of the internal RAM?
No idea.
It is 128 bytes. We have 128 bytes of internal RAM. Okay. And we have something called special function register. On this point, I will come later. Special function register, which will be used for some of the special functions. I'll let you know when we come to that point. So we have 128 bytes of SFRs. And how many ports do we have? When I was explaining you this pin diagram, I said like we have this many number of ports and this many number of pins in that. So how many number of ports do we have in 8051? We have 4 ports. 4 ports. In each port, how many pins do we have? 8 pins. Clear?
Yes, sir.
So total 32 pins. Okay. And how many timers do we have? We have 2 timers, each of how many bits? 16 bits. These are the features, okay? Whatever I am mentioning, these are the features of 8051. They will ask you what are the different features of 8051. That is also one of the important questions.
Okay.
And we have total 5 interrupts in 8051. 5 interrupts. And we have one full duplex serial IO, input out. Okay. This is the overall features of 8051. Next, we come to the architecture of 8051. Okay. So, yeah. So that architecture we will discuss in tomorrow's class. Okay.
Okay, sir.
Oh, thank you.
Thank you, sir.
Yeah, I'll share you the recording in some time. You can go through that as well. I mean, you can keep revising. So if if you are like not getting any points, you can just revise and check that recordings again. Okay. Thank you.
Okay, sir. Sure. Thank you.